Welcome to my YouTube channel. Dhanesh here. So today we are going to discuss about back propagation. So back propagation is an algorithm we usually use in machine learning and in artificial neural networks. So this back propagation aims to minimize the cost function. So the back propagation is used to minimize the cost function by adjusting the network weights and biases. See, cost function we already discussed. Cost function, it's also known as error function or loss function or objective function. See, all these terms denotes the same thing. It is cost function or error function or loss function or objective function. See, all these terms denotes the same aspect. See, cost function in machine learning, artificial intelligence, even this cost function is used in economics and statistics. See, this cost function denotes the error. See, in a machine learning perspective, see, cost function denotes the error. Error means, in the case of machine learning, error means the predicted value minus expected value. See, for a machine learning model, see, we will give, we use the machine learning model for prediction, you know it. Well, the predicted value minus expected value, that is the error in the case of a machine learning model, and the cost function denotes the error. And in the case of, I am considering a simple hypothesis here. It is this is a hypothesis or a machine learning simplest machine learning model. So this hypothesis, this is the following: the y is equal to mx plus b. So y is equal to mx plus b denotes a machine learning model or a hypothesis. Here m is the weight. See, weight is denoted by the letters. Sometimes it is denoted by w or theta. Theta, we will use theta as well. So the angle, theta is usually theta denotes the angle. So weight is determined by the, weight is denoted by w or theta, or here we are using m in the simplest form. So weight in this equation, y is equal to mx plus b, it is the equation of a straight line, and you can understand it is, it is the equation of a straight line, and in that equation m is the slope and b is the y-intercept. So for a machine learning model, this slope or gradient, we call it as the weight of the network, and b is the bias. And this back propagation, or we call it as the backward propagation of errors, is an algorithm for supervised learning of artificial neural networks using gradient descent. So back propagation or backward propagation of errors, we are feeding back the errors again back. It is, back propagation means it is the backward propagation of errors, and this algorithm we usually use in artificial neural networks, and this algorithm is implemented by using gradient descent. So in this video we are going to cover, see, what is back propagation. We already discussed it, and now I am going to talk about the cost function or loss function or error function. So backpropagation means it is the backward propagation of errors in the case of a neural network, and this we use to minimize this. We are using to minimize the cost function by adjusting the network weights and biases. See, what is a cost function? See, weights and biases, I already told you. See, weight is the gradient, and bias is the intercept. In the simplest way we can express in that way for a hypothesis. Now I am going to tell you what exactly is this cost function. So I already told you cost function. One important thing, cost function is denoted by the letter cost function. It is denoted by the letter G. Cost function, it is denoted by the letter G, and this function determines the performance of a machine learning model. It determines the performance of a machine learning model, and cost function gives error. See, error means I already told you the machine learning model we are using for prediction, and the cost function is equal to, we can write it as the predicted value minus expected value. And cost function has two purposes. One is it is used to minimize the error. As I told you, we need to minimize this predicted minus expected. This value should be minimized. It is used to minimize the error. And second one is it is using to maximize the reward. See, in that comes into picture when we talk about the reinforcement learning. So you already know this machine learning is of three types. One is supervised machine learning, second one is unsupervised machine learning, and third one is the reinforcement machine learning. So this reward you will understand in the case of reinforcement machine learning. So I can tell you this is the reward. It is mainly associated with reinforcement machine learning. That aspects we can discuss it later. For the time being, you can understand it as the the cost function we used for two purposes. One is to minimize the error, and the second one is to maximize the reward. And again, I discussed y is equal to wx plus b. It is the hypothesis or the machine learning model we use. Here y is known as the predicted value. See, all these parameters I can explain you once more. See, y is the predicted value, and x is the training data. See, in this hypothesis you can clearly understand. I will tell you. This is what we are going to discuss now. Say y. See, y is equal to wx plus b. It's a simplest equation of a straight line. It's nothing more. It's simple only. So in this equation, if you see this wx plus b, here y. What is y? It's the output. It's we can tell it as the output, or it is the predicted value. X. What is x? X is the input or the training data. What is w? It is the weight, and b is the bias. And this cost function, I already told you, it depends on two parameters. One is the weight and the bias. So I have written it's a function of weight and bias. That's what I have written previously. So it's a function of weight and bias. Cost function, it depends on two parameters, weight and network weight and the bias. And one more aspect I need to tell you, it is the cost function. It is classified into two. One is the mean absolute error, and the second one is the mean squared error. So this is really important. There are two types of cost functions we use. One is the mean absolute error, and the second one is the mean squared error. So we call it as MAE, and the second one we call it as the MSE. So there are two types of cost functions We already covered C, that is MAE and MSC. If you want to know more about this, mean absolute error and these aspects, MAE and MSC, I can give you some more idea about that. It is like here we have the equations for the mean absolute error, and this is this whatever we are representing here, it is sigma 1 by, this is mean squared error. See, you will get it more clearly in this equation. So I told you about mean absolute error and mean squared error. So mean absolute error, this is what I am going to tell you. This is in this equation. If you see, this is the mean squared error, because you can see here, see, this is all about mean squared error. See, mean squared error is equal to 1 by n sigma I is equal to 1 to n error square. See, what is error? Error is the predicted value minus actual value. See, sigma denotes summation, another mathematical operation we use for summation is integration. See, integration, it's a part of calculus. See, integration is also a type of summation only, but it is more accurate and more precise. So sigma I is equal to 1 to n. Here n is the number of samples, I is the index of the sample, data sample, right? So the data set, index of the data set. See, n is the number of samples and I is the index of the sample, and error square. See, why we are using square here? So there are two methods, because the reason is, when you talk about a machine learning model, error is the predicted value minus actual value. But sometimes the predicted value can be higher than the actual value, then error is positive. If the actual value is higher than the predicted value, then the error can be negative for a particular sample. So when you sum this positive and negative values, you won't get the exact result. You won't get the accurate result. So that's why normally when you square it, the square of a negative number is positive and the square of a positive number is also positive, and you will get the exact result. So that's why we are using error square. So the predicted value minus actual value can be positive or negative. So when you add this positive and negative numbers, you can get 0 as well sometimes, or you won't get the accurate result. To get the accurate result, you square the error. And here in the next equation, see, error means predicted values. This is error. See, here this is the error. Error, it is error is predicted value minus actual value. This is the error. And instead of error, you can substitute y dash minus y. See, what is y dash? Y dash is the predicted value and y is the actual value. Predicted value means it's the machine learning hypothesis. Am I right? So the prediction is done by the machine learning hypothesis or the machine learning model. So y dash is the machine learning hypothesis and y is the actual value or the expected value. You can tell it as the actual value, or the this is the expected value here. So that's from the this is the expected value. See, this is what we discussed. See, y dash minus y. See, y dash is the a predicted value that we are getting from the machine learning hypothesis, and y dash can be substituted as mx plus c or mx plus b, where m is the weight of the network and b is the bias. See, that's what we have done. See, mx plus c. So where m is the weight of the network and c is the bias, or you can use b, any letter you can use and here B is the bias. So this is the most important equation for this is the mean squared mean squared error. So I was I completed that portion. This is known as the mean squared error. Instead of y dash, you substituted mx plus b, because y dash is the predicted value. So that's from the machine learning hypothesis. So I can substitute mx plus b minus y the whole square. So that is about mean squared error. And that's about the mean squared error. When we talk about the mean absolute error, see what you will do is, instead of squaring, you will take the modulus. So instead of all sigma 1 by n, sigma, all those things, it's remaining the same. Instead of square, you will put modulus. If you see this equation, this 1 by n sigma I is equal to 1 to n remains the same. Instead of square, you will do the modulus. So modulus means the equation should be, I can write it in I will show you that equation. This is what I can tell you. If you see, this equation can be written as the modulus. See, the error I am talking about is the mean absolute error, right? See, it is that's what we see. Mean squared error I already discussed with you. See, mean squared error, there are two types of errors we discussed. One is the mean squared error and mean absolute error. MSE, mean squared error, I already covered with you. Mean squared error, it is I have written as mean squared error. I can tell you, just 1 second. Mean squared error will be mean squared error. Just let me take the brush. Okay, so now you can see it as mean squared error I already covered. It is if I am talking mean that we covered. Now I am talking about the mean absolute error. See, what is this mean squared error and mean absolute error? It is, there are two types of cost functions. That's what we are discussing. One is the mean absolute error and mean squared error. So mean absolute error should be 1 by n. This is the formula. 1 by n, then sigma I is equal to 1 to n. N is the number of samples in the data set, and I is the index of the sample. Then the modulus. See, the modulus of a negative number is positive, and here again you can write it as y dash minus y, predicted minus expected. So this is the equation for the mean absolute error. So this is the second type of cost function. MAE is 1 by n, sigma I is equal to 1 to n, y dash minus y. See here, why we are using the modulus means the same explanation. Why we use the square? The reason is, when we square it, we will, what we can understand is the negative numbers becomes positive. And when we, take the modulus, the same thing, the modulus of a negative number is positive, and the modulus of a positive number, not positive, the magnitude, that's the correct thing. See, the modulus of a negative number is the magnitude itself. There is no sign. The modulus of a positive number is also the magnitude itself, 5. If it is positive 5, the modulus is 5. If it is negative 5, the modulus is 5. So we no need to worry about the sign, and if we are considering both positive and negative values, what will happen is, the exact result won't be the same. Sometimes these positive and negative values sum up and it becomes very less or zero. To avoid this, two methods we are using. One is the modulus, another one is the square. So we covered the cos function as well. See, now I am getting into the back propagation. That thing only I told at that time. See, the back propagation, this it is an algorithm. It is implemented by using gradient descent. So I will give you some idea about gradient descent. So if you want the detailed study of gradient descent, I have created a playlist for gradient descent. There contains the 5 videos related to gradient descent. See, there I have explained calculus, what is differentiation, what is integration, how you can find out the maxima and minima of a function using calculus. All these aspects I covered. I mean, those gradients, around 5 videos it's uploaded. But here related to back propagation, this algorithm, this backward propagation of errors, it's an algorithm we are using an artificial neural network, and it is again implemented by using gradient descent only. So I am just giving some idea about this gradient descent algorithm. So in this algorithm, what you need to understand here is, see, I can tell you this gradient descent. Now this is what you need to understand. So gradient descent, this is an algorithm we use. I can tell you it is an iterative optimization algorithm. See, gradient descent, it's an iterative optimization algorithm, I can tell you. So it's a really very important topic related to machine learning, deep learning and artificial neural networks. So gradient descent, it is an iterative, it's a repetitive process, iterative and optimization algorithm. So what we are optimizing here, that's what I am going to talk about. So I will give you some idea about the gradient descent algorithm. So gradient descent, the point here it is, so our aim is the machine learning model we are using for prediction. So when we are doing the prediction, the error must be minimum. That means the cos function denotes the error. Am I right? So the cos function must be minimum. To minimize this cos function, we are using the gradient descent. See, the cos function, it is denoted by the letter J, and it depends on the weight and the bias of the network. Two important parameters. If you have a hypothesis like y is equal to mx plus b, where m is the weight and b is the bias. It's a simple equation of a straight line. M is the weight of the network and B is the bias. So to minimize the gradient descent, we have to optimize between the weight and bias. So that's the really important thing. The cos function will be minimum for a particular value of weight and bias. So we need an optimization between weight and bias of the network. So how do we find out the minimum of a function? That's important. See, in calculus, you have methods to find out the minimum of a function. You can take the first order derivative. See, those who are not familiar with mathematics, see, calculus, it's a branch of mathematics introduced by Sir Isaac Newton and Leibniz. And here there are two sections. One is differentiation and another section is integration. See, differentiation means you are splitting. You are doing, splitting a physical quantity or any data. You are splitting into smaller parts. Integration means again you are summing. It's like a summation only. Again, adding all those data. That is integration. See, in this, when you differentiate a quantity, you will, whatever you are getting the output, we call it as derivative. When you differentiate a quantity, Or when you differentiate a variable, the output you are getting is known as the derivative. When you integrate, the output you are getting is known as the integral. So here in gradient descent algorithm and the artificial neural networks calculus, it is an important calculus, lot of equations related to calculus we are using. So what we are discussing here is we need to find out the minimum of a cost function. We need to find out the minimum of a cost function or loss function or error function or objective function. All these are all same. So to find out the minimum of a cost function, we can use calculus. So by the method of calculus, what you do, for example, if you have a function like fx is equal to x square, the x square I can write it in the it would be better if I am writing it in the paint, same so you will get it more clearly. So I have a function like fx is equal to x square minus 2x plus 1, x square minus 2x. This is the function, right? Function means it contains two variables. One is the dependent variable and independent variable. Fx means it's y, see it denotes y only. Y here it is the y is the dependent variable here and x is the independent variable. So this dependent variable depends on x, so that's why we are writing it as a function of x. So to find out the minimum of this function, what you will do is you will find the derivative. Derivative means dy by dx. You can call it as a dy by dx or f dash x, both are same, dy by dx, or you can call it as f dash x. In calculus differentiation, both are same only. This is f dash x. So this is what when you calculate the derivative of this, the derivative of x square, it is 2x. The derivative of x square, it is 2x, and we are using this equation. If you don't know the fundamentals of calculus, then you can understand this. D by dx of x raised to n, d by dx of x raised to n is equal to n x raised to n minus 1. This is the equation we are using it here. So f dash x, then x square becomes 2x raised to 2 minus 1 by using this formula. 2x minus, then you will get here you will get minus, again x, the derivative is 1, so 2x minus 2. The derivative of a constant is 0, 1 it is 0. So this is f dash x, and we will equate it to 0 and we will find out the value of x. So here x will be, when you take 2 common, you will get it as x minus 1 equal to 0. That means x is equal to 1. So at this value, this function becomes minimum. This is the first order derivative test. There is another second order derivative test is also there if there is a function is having multiple maxima and minima. If there is only one minima, we can use this test, the first order derivative test, then we will get this function, if this is the cost function, this is minimum at x is equal to 1. The process, this is the gradient descent, is also a process to find out the minimum of a function for a particular value of x. That's what you need to understand. So gradient descent is also a process to find out the minimum of a cost function for a particular value of x. then you will think, why can't we use the calculus method? See, why we can't use the calculus method is this fx, the function is a simple function. If the function is something complex like e raised to sin x into a raised to x into b divided by 4 pi e raised to cot x into tan x, like that, if it is a very complex function, you can find out the derivative, first order derivative, but when you equate it to 0 and solving for x, it's a very complex process. That's why the calculus approach won't work all the time. That's why we are getting into the gradient descent approach. So let me talk about the most important algorithm we are using in machine learning, artificial neural networks. So let me talk about the gradient descent algorithm. So in gradient descent, what we usually do is, see, again I have given the function here. It is fx is equal to x square minus fx is equal to x square minus 2x plus 1. So this function, if you see here, the f dash x, you can calculate it. You can calculate the f dash x here, and you can find out the minimum of the function. See, the gradient descent algorithm, what exactly uses the equation, how they are used, the most important equation they are using is, this is the equation you are using in the case of gradient descent. X of I plus 1 is equal to xi minus alpha into f dash xi. See, x of I plus 1 means the next data. I stands for the index of the data, index of the sample. See, x of I plus 1 is equal to xi minus alpha. What is alpha here? Alpha is an important term. We usually use it in statistics and machine learning. It's called, we call it as the learning rate. Alpha is known as the learning rate. See, alpha, its maximum value is 1 and its minimum value is 0. See, alpha means it is the step length. See, we need to do in the gradient descent algorithm, see here we have found it out, like x is equal to 1 is the minimum of that function. In gradient descent algorithm, the approach, see, I didn't tell the approach properly, so now I am giving you how it works. See, we know here x is equal to 1 is the minimum value. At x is equal to 1, the cost function or the function is minimum. But we don't know, if we have a complex function, we can't use the calculus approach. Now we are going to do the gradient descent approach. So what we do here? So what we do here is we will take a wrong value. So we will assume like we are assuming like let x is the minimum. Let x is equal to 2 is the minimum. Let x is equal to 2 is the minimum. We are assuming it. At that, in this value, the function is minimum. That's what we assumed. Now we will calculate f dash x. Then if this is the minimum value, f dash 2 must be 0. Am I right? If the function is minimum at this value, then f dash 2 must be 0. But since it is not minimum, f dash 2 we will get a value, and if f dash 2 is positive, so you will calculate, what we will do is, you will calculate f dash, first you will find out f dash x and substitute f dash 2. Then if f dash 2 is greater than 0, if it is a positive value, then you will go back, you travel backward, then you will take x is equal to 1 point, you can take 1.5 or 1, like that you can take it and again check it. If f dash 1 is 0, then you assume that this is the minimum value, the minimum of the cost function. If f dash 2 is negative, if f dash 2 is less than 0, what you will do? You will travel in the opposite direction. Then you will calculate for x is equal to 2, f dash 2 is negative, then you will calculate with x is equal to 3. Like that you move in the opposite direction. That's what you do in the gradient descent. See, this logic we implement in a Python program. See, it's already we have done it, and it is there in the, so you can see the playlist, gradient descent in my YouTube channel. A Python program is implemented, how you can do the gradient descent algorithm. So this is the concept. See, the gradient descent when come into picture means some functions we cannot solve by using the calculus method. At that time we will take a random number for x is equal to 2, and we will calculate f dash 2, and any number that shouldn't be like x is equal to 2, any number you can take. Let us assume that we have taken x is equal to 2. Then if f dash 2 is a positive value, then we will try with 1. If f dash 2 is a negative value, we will again go forward, x is equal to 3, x is equal to 4, like that. So if f dash 2 is greater than 0, we will again come backward. So we will try with x is equal to 1, x is equal to 0, like that. See, this is the approach. See, this thing we can put it in an equation. That's what we have done here. X of I plus 1 is equal to xi minus alpha into f dash xi. So we are in the f dash x only, in the derivative only, we substitute the value. Why this alpha? See, alpha, it's known as the learning rate. See, alpha we call it as the learning rate, and we use alpha. See, I can tell you alpha we call it as the learning rate. This term is always associated with statistics, machine learning. So, this learning rate will usually, even in statistics we use, and in machine learning, neural networks, deep learning, everywhere this is a very important term. It is known as learning rate, and it is denoted by the letter, Greek letter alpha. You know this letter, alpha. And its maximum value is 1. It is between 0 and 1. This value, its value is between 0 and 1. If it is very less, if the learning rate is very less, so what is learning rate? See, learning rate, I told you, we need to assume some value for x, and we need to, do multiple iterations in this gradient descent. We need to do multiple iterations to come up the final value. I already told you. See, that's why gradient descent, that's why we are defining like that. It is a repetitive process. It's an iterative process for it's a gradient descent. It's an iterative optimization algorithm. See, optimizing weight and bias. Why it is repetitive means we are assuming a wrong value and we are optimizing. We are doing multiple steps. So when we do the multiple steps, what is the step length? What is the length of those baby steps we are taking? That step length is known as the learning rate or alpha. You are getting my point? So learning rate, it is the step length. It is how much what is the length of the baby steps. Step by step we are iterating. We are taking x is equal to 2, then x is equal to 1, then you can take x is equal to minus 1, minus 2. So which, at what level this f dash 2 becomes, f dash x becomes 0. That is the minimum of that function. So in that we will change that steps. So we come from 2 to 1. Say we are reducing it, then again it is so how many iterations we need to take, so that we call it as the learning rate. So how many in that iterations, what is the step length? that we call it as the learning rate, and its minimum value is 0 and its maximum value is 1. If it is 0 means, if it is very less means the training of the machine learning model happens very slowly. That's what it means. If it is very high means we will get undesirable outputs for the cost function. So that's the meaning. So it should be in between. You need to do a program and you need to find it out. See, you can see the implementation in the previous videos related to gradient descent in Python. So we need to do trial and error, and we need to get the optimal. See, we need to optimize the weight and bias, and finally come up with the minimum of the cost function. So the cost function will decrease and then increase. See, when you take a function, so I can show you, here, sorry, you can see it here. See in this figure, if you see it in this figure, you can see here, this is the plot of this graph. See, this function is minimum at x is equal to 1. So this is 1 and this function is minimum. So once it becomes minimum, then it increases. So in that way, when you do the program as well, you can understand it becomes minimum and then increases. So you will get that point. So for that, this is the equation we use. So I plus 1 is x of I plus 1 is equal to xi minus alpha into f dash xi. See, what is this f dash? That is the derivative. See, derivative is denoted by here it is the partial derivative dou. Dou stands for partial derivative. See, when partial derivatives comes into picture, see the cost function, we are talking about cost function. So it depends on two variables. One is the weight and the bias. So I will, if you want, I can tell you about the partial derivative. For example, you have a function f of x, y, two variables. So this is a very important aspect you need to understand. The function is f of x, y. This function depends on two variables, x square plus y square. So this function can be differentiated with respect to x. So this will be that will be dou of f of x, y with respect to x. When it depends two variables, then the concept of partial derivatives comes into picture. So this is, we are differentiating with respect to x. At that time, y is a constant. What is the derivative of a constant? It's 0. So what is the answer should be 2x. This rule we already discussed. dy by dx of x raised to n is nx raised to n minus 1. So when this function is differentiated with respect to x, it is 2x. At that time, y is a constant, and when this function is differentiated with respect to y, so the function is when we differentiate with respect to so when we differentiate with respect to y, what will happen is like dou f by it will be dou y, right? See here also you need to write x comma y. I didn't write it here. I am writing it x comma y. Okay, because it depends on two variables. Then it would be 2y. So at that time, which is a constant? X is a constant. You are getting my point. So this time x is a constant and it is 2y. So you got this point. So this is the concept of partial derivatives. So when partial derivatives comes into picture is when a function depends on two variables. So the same case, see this is what happens here as well. Our cost function depends on two variables. One is weight and bias. So the partial derivative of dou j by dou m. So this, if you want to understand it, is I have the even in the previous videos you can check the gradient descent playlist. So it's given here. It is 2 into error into x. See how you are getting this equation is when you differentiate this equation. See, this is error, mx plus b minus y. This is predicted minus actual. So that's what mx plus b minus y. This term only I am taking it as error. Its derivative is 2 into error, and we are differentiating with respect to m. At that time, x is a constant, b is a constant, y is a constant. So you will get the derivative of mx is x. So that's why you are getting it here 2 into error into x. When you differentiate this term with respect to y, you will get 2 into error. Then what is the derivative of y? It is 1. When you differentiate, so that's 2 into error. So this is really simple. See, the formula we are using is nx derivative of x raised to n. It is n x raised to derivative of x raised to n, it is n x raised to n minus 1 only. So it would be when we differentiate with respect to m, this 2 into mx plus b minus y, that is 2 into error, then this mx. So when we differentiate mx, you will get x. There x is the constant and m is the variable. You need to understand. Everywhere x is the variable and other m and a, all other things are constants. Here our variable is the weight m, and when you do the partial differentiation, these variables are again constant. Sorry, these b and y are not variables; they are constants. Sorry. And when you differentiate this, again 2 into error. What is the derivative of y with respect? Sorry, what is the derivative of b? This y and mx are constants. Only variable is bias b. That is the derivative of b is 1. So that's why you got it as, I can tell you these two equations. That's why you got it. Dou j by dou m is 2 into error into x, and dou j by dou b is 2 into error. And this equation, the x of I plus 1 instead of x, we can modify it as m of I plus 1 is equal to mi minus alpha f dash x I will be dou j by dou m. When we talk about m, so this equation we have rewritten for weight m. So and dou j by dou m you can substitute as 2 into error into x. So this dou j by dou m you can substitute as 2 into error into x. And this equation again rewritten for bias, b into I plus 1 is equal to bi minus alpha into again dou j by dou b. Dou j by dou b you can substitute as 2 into error. This is the gradient descent approach. This is the way. So we have implemented a Python program in the previous videos. You can see it in the gradient descent playlist. So this is the gradient descent approach for doing the backpropagation. So in this video we covered some of the most important aspects in machine learning, neural networks as well. That is backpropagation, cost function, and gradient descent. So that's all. Thanks for watching.